the nature of matter, and from the beginning of the class, or beginning of this class, we're defining chemistry, and we say that chemistry is simply the branch of science that deals with the study of the, first of all, the structure, the nature, the form of matter, and how matter interrelate with nature. Okay, so let me just go there. Let me not quote from my head. Chemistry is defined, this is the definition of chemistry from the note. Chemistry is defined as a branch of science which deal with the study of the nature. Nasir, I can't even control here. Nasir, please mute your mic. Nasir, my God, please mute your mic. Mute your mic. I think I can mute. I'm muting. Good. Just tell her that you're making noise. Okay, so let's carry on. We'll carry on from here. So we are saying that chemistry, I'm going to just go back to recap on our previous classes. So we say chemistry is a branch of science which deal with the study of the nature, structure, composition, properties, and uses of all forms of matter, and the changes in structure and composition which matter undergoes. That's chemistry. So chemistry is all about the study of matter, the study of the structure, the study of the nature, the study of the composition, the study of the properties of matter. All right, so we carry on from here, and we are saying that we're going to study what is matter today from the topic that we have today. Please go to the group. The lecturers that sent this evening, you see you'll find today's topic there. I can't share my screen because I'm on voice call, not video call. All right, so nature of matter. Hope you can hear me. Miss Comfort, can you hear me? Okay. All right. Yes, sir. All right. So we're looking at matter. So we say that matter, from the note, matter is anything that has weight and occupies space. Anything that has weight and occupies space is called matter. Now we say matter exists in three states. Yes, matter exists in three states: solid, liquid, and gas. So there's the solid nature of matter, there's the liquid nature, and there is the gaseous nature of matter. Now, the fundamental difference between the three states of matter depends on the degree of movement of the particles they are made of. So what makes the solid state of matter different from the liquid state of matter is the degree of the movement of the particles that are combined to form the state of matter. I don't know if I get what I'm saying here. So if we look at the solid state of matter, there are certain properties there are certain particles that are combined, that come together to form the solid state of matter. And if we look at the liquid state of matter, there are certain properties that come together to form the liquid state of matter. If we look at the gaseous state of matter, where there are also properties that are combined or that come together to form the gaseous state of matter, so to say. So that's what we are seeing here. All right, let's carry on. Let's look at the different state of matter that we have. So we have number one, we have the solid state. That is the solid state of matter, the solid state. And here in the solid state, the particle, please follow carefully, as I explain, follow carefully. The particles of a solid are tightly packed and held together by a strong electrostatic force. So the particles of the solid state of matter are held tightly, are tightly packed and held together by electrostatic force. An electrostatic force is a force that is produced where electric charges, that is a force that bring about the attraction or repelling of electric from electric charges. What I mean here is that There are certain electric connections or charges that repel. There are some that attract. All right. For instance, if you mistakenly join the red wire. Let me use wire for example. You join the red wire to the black wire and the black wire to the red wire. It will repel. It will almost, if you are using generator, to almost explode. Do you understand? So they are saying here that these solid are held together strongly by electrostatic. There's a force that hold the solid form of matter together. Okay, so let's carry on. Now they said the particles only vibrate to and fro about an equilibrium or a fixed disposition. The word equilibrium is fixed position, all right, or a fixed point. It's called equilibrium. Okay, where everything is at the same level. All right. So they're saying here that the particles of a solid state of matter vibrate to and fro about an equilibrium or a fixed position. Now let's carry on. They are a definite. Now solid state of matter have a definite shape and volume and very difficult to compress. For instance, if you look at your, if I should use your let me use a table in your house for as a or let me use your mattress. Your mattress is a solid state of matter, as it is. It's a solid, right? Or okay, let me say yes, it's a solid. Now they are here to say that they have a definite shape, so you can actually tell that my mattress is rectangular in shape, or it is square in shape. It is cuboid, or is a cube in shape. All right, you can actually tell. Why? Because it is solid. All right. Then also the volume, you can tell, like your gas cylinder also is another example, which is also solid. It's form of state of solid. The gas cylinder, not the gas itself, the cylinder itself, a cylinder. So the cylinder is solid, and you can tell the shape of the cylinder, which is called a cylinder. Actually, a shape of cylinder. And the volume, you can say this gas can contain 5 kilograms of gas. The gas cooker can contain 5 kilograms of gas. All right, it is solid. You can tell the volume, you can tell the shape, you can't just combine, you can't just squeeze it and form it to make it look little. Do you understand what I mean? Let me say ice block, for example. You cannot just hold ice block easily and compress it to become small. You cannot hold your mattress and compress it and it becomes small. No, it's not that easily compressed. That's what I'm saying here. So the solid state of matter, like I said, they are tightly packed, held together by a strong electrostatic force, static force. Then now you see this particle only vibrate to and fro about at the same level, right? What it means is that if you should kick your mattress, even the other end of the mattress will be affected. That's what I'm saying here. All right. Now they have a definite shape, like that. One of the characteristics, definite shape and volume, and very difficult to compress. That is that for the solid state. Then we move to the liquid state. Now in the liquid state, the forces of attraction between molecules of liquids are weak compared to that of solid. So we know that here the forces of attraction of the particles that makes up the state, that matter. For let me use water for example. If they have what is we say is H2O, that bit of water, that is hydrogen and oxygen, right? Hydrogen and oxygen makes up water. So the particles, the chemical composition, which is hydrogen and matter, these are that come together. The forces of attraction that brings them together are not as strong as in the case of solid. I don't know if you get what I'm saying here. Are not as strong as the case of solid. That's what I'm saying here. So he said the forces of attraction between molecules of liquid are weak compared to that of solid. Now, hence, they have slight movement. They have not fixed movement. They have slight movement. Now, this is why liquid can flow. The reason why your water is able to flow even on tiles, if it can flow on the river, it is because it have slight movement. Okay. Now, they have definite volume but not definite shape. You cannot say water is circle. You cannot say water only form the shape because based on the object you put it inside. If the tank is square in shape, the water will give you square shape. If the tank is round in shape, it will give you a round face, right? If the tank is triangular in shape, if the container is triangular in shape, it will give you a triangle. I hope you're following me. So water has no definite shape, but it has a definite volume. So you can actually you can only figure out and say this is 3 kilograms, so the 3 liters of water. By fishing it, you can actually tell the volume of the water, but you cannot tell the shape of the water. Do you understand what I'm saying here? So liquid state of matter are shapeless, but while solid shape of matter has definite what? Solid state have definite shape. Next one is gaseous state. Okay. Now, as a result of the distance between the molecules of gases, the cohesive forces, that the powerful forces between them are very negligible, okay, and so they move randomly. Gases have no definite shape and volume, so you can hear that gases don't have a definite shape, gases don't have volume. All right, they assume the shape of the containing vessel. So your gas cooker, if your gas cooker can contain the gas that can be contained in your cooker is depending on the size of your gas cooker. For example, you cannot carry, even though the gas will not stop itself from entering into a 5 kg. You cannot say you want to put 12 kg inside 5 kg gas cylinder. It's not going to be possible. Why? Because the capacity is too small to host it. Okay, to host 12 kg. So that we are saying here that it has no volume, all right, but the cylinder can tell, okay, this is the amount of the gas that is contained here. So that we are saying here, and it has no shape because it's like air, like gas, air like. Okay, so let's carry on. Hope you're understanding, hope you're following. All right, let's carry on. Okay, hold on, I'm coming. Okay, let's move further. So we're looking at, if we move in the next page, in the next note, you see comparison between solid, liquid, and gas. Comparison between the differences between solid state of matter, liquid state of matter, and gaseous state of matter. You may be asked this question: what is the major difference between liquid, solid, and gaseous state of matter? You may be asked this question in an exam. What is the difference between them? And the difference is very simple. That solid state of matter, what the particles that form it are tightly packed and held together by a strong electrostatic force. While liquid, the molecules that makes it up are weak. That means the particles are not strongly held together. The particles are weak as compared to that of solid. While for the case of gases, the molecules they are not even close. They can't be held together. The molecules that form the gaseous state of matter cannot be held together. All right, that are separated, and that is what makes them gaseous. That's why they can evaporate. That's how come if you open your gas and keep and you come back, the gas may escape all. But in the case of water, it may not escape that easily, that quickly. Though it will be escaping as evaporation takes place, but the evaporation of water is not as fast as that of gas. Okay, because of what the molecules that mix them up, the composition, the closeness, the proximity of the molecule. That of solid are very close, so they are tight together. That of liquid are a little far, they are not too far. That's how come they are loose. That's how come water can flow. That's how come water can move. All right, that of gas are not close, they are far from each other, so the molecules are not tightly held together, they are separated. I don't know so the simple difference here is the distance of the particles, the distance of the molecules that form those state of matter. It what makes them different. That of solid are strongly held together, the distance is close. That of liquid a little bit close, not too close as that of solid, while gaseous they are not close at all. I don't know, getting this explanation. Are you getting it? Please unmute your mic, let me hear you. Are you getting it? All right, let's carry on. Thank you. Now let's look at that's one of the difference. Then the other difference we have, number one, for the solid state of matter is fixed. The solid state of matter is fixed. The liquid state is also fixed. All right. The gaseous state is also fixed. Okay. Next one, the liquid state, so the solid state is very dense, that means very heavy. If you put if you carry a 10, let me use that paint rubber, that 20 liter paint rubber that paint rubber. If you put sand inside of it, you will discover that if you put sand in one, I wish we are in physical class would have done experiment. If you put sand in one and you put water in one, you will realize that the one that is carrying sand it will be more heavier than the one that's carrying water. Do you understand? So very dense. That of solid is very heavy, very dense. Then that of liquid is less dense, not that heavy for the liquid. Then that of gas is least dense. If you put gas in that same kind of distance, it will not be that heavy. It won't be that heavy as compared to solid or liquid. The next one, number 3, solid have definite shape. So like I told you, you can say my mattress, which is solid, or if you do ice block, if you put ice water and it blocks, you can tell the shape. You can carve it to any shape you want to carve it to, because it's what liquid is solid. Do you understand? Then liquid is shapeless. Liquid has no shape. I told you, if you carry water, if you put in a triangular tank, it will be water will do triangular. If you carry the same water and put in a circle tank, it will give you a circular shape. All right. The next one, also for the gases are also shapeless. Any container, it assume the shape of the container you put it inside. The number 4 is definite volume. So solid has a definite volume, so you can actually tell the volume of your gas cylinder, the cylinder itself, which is solid, right? You can tell the volume. Then liquid also has definite volume, so you can tell the amount of liter of water. Then gas has no volume. So that is it. The next one, number 5, is incompressible. So liquid are incompressible. You cannot compress liquid. Sorry about that. Solid. You cannot compress solid. You cannot compress it. Then for liquid, can also be compressed. Okay. Gases are compressible. Then the next one, number 6, is the particles for solid. The particles of the solid vibrate and move about a fixed position. Then for liquid, particles vibrate, rotate, and move about a restricted space and at a fixed speed. That means in that of liquid, the particle vibrate, rotate, and move about a restricted space. That is how come the water as long as that water is not more than the volume it should carry, the water will not leave its boundary. It will be within the boundary as long as the container has not broken. Okay, as long as the container is at a fixed. It can be restricted in a particular place at a fixed speed. So there are times that water is moving at a very high speed, okay, and the other side will be moving in that location. If you go to the river, there are places in the river the water is moving at a very high current, very high speed, and there are places moving very slow. All right, so that is what I'm saying here. In a restricted place at a very fixed speed. Then for gas, the particle move about constantly. So gases are not stable. They are just moving. That's like air. All right, the air is just moving. Air is not static. All right, the particles are moving from one location to another. I don't know if I'm getting this illustration. All right, then let's move further. Let's move further. Okay, let's further. Let us move further. Let's move further. Okay, I'm coming. Let me respond to someone. All right. So looking at changes types of changes in matter. That means the changes that matter undergoes. All right, there are changes matter undergoes. So matter, even as it exists in three states, this state is possible that it can be changed. It can change from one state to another. Okay. So matter can change from one state to another. So that's how come you can carry your liquid, your pure water that is liquid, and you subject it to freezing. Freezing will make that the particles, the oxygen and hydrogen that makes up the liquid will form and come very close, and that is how come they form an ice block. Okay, so they by the activity of the molecules that bring about freezing, it will combine, it will bring the molecules, that's the hydrogen and oxygen, and bring it too close that they will not form block, they will not form solid. All right, that is one of the change that happen. And that same water, if you subject it to heat, it will become liquid again. Then if you subject it to an intense heat again, it will become gaseous. That is how come if you're cooking food, when you open the pot, you will see like at the cover, you will see like water dripping, right? And if you open it, you will see something like vapor, heat, evaporating, as if it's ascending. All right, it's ascending up. That's the gaseous state of the water. If you leave that pot boiling and open, the water will dry off and it will become gas. So that is how come. But that's how that's how matter changes from one state to another state. Okay, so let's look at it here. We're looking at types of changes of that occurs in matter. All right. So let me read from the note. Whenever a given substance is heated, now listen. Whenever a given substance is heated, its state changes. So when you subject a substance to either heat or freezing, cooling, its state will change. Now, the two types of changes are, there is the physical change and there is the chemical change. Physical change and chemical change. Now let's look at the physical change. A physical change is a change which is easily reversible and in which no new substances are formed. Physical change is a change which is easily reversible. So it means that if you decide to turn your pure water to block, you can turn it back to liquid again. If you turn it to solid, you can turn it to liquid again. It's possible, very possible. All right. So through the process of freezing, you can or refrigerating, you can either turn it to liquid, turn liquid to what, solid. Then later on, by heating it, you can turn it back to liquid again. So a reversible physical change is reversible and there's no new substance formed. It's the same water. So the same pure water you use to change to solid, the same pure water that you can change back again to what, liquid. Is very straightforward. Are you with me? All right. Are you with me there? Let us carry on. Okay. The next one, okay, let's look at an example of physical change that occurs in matter. Number one here is physical change of matter. Example is dissolution of common salts. Dissolution of common salts. So there is salt. So what this means is that if you decide to dilute the salt, let's say if you decide to add water to sodium chloride, you know that the sodium chloride, salt is simply sodium chloride. When you now add hydrogen, which is water, it becomes liquid, right? Now, it doesn't mean that salt is no longer salt. It's still salt. The content of the salt has not been lost. It's just that they have been diluted. That means the potency may not be as strong as it is, but it isn't the same amount of salt that is there. So if you will fetch a teaspoon of salt and put inside water, and dissolve it from concentrated nitrogen, sodium chloride, and you now add hydrogen to it, what is going to happen here is that you see the same salt. Now, if you decide to heat that water and the water all evaporates, you see how the same 1 teaspoon of salt that you put. So the substance still does not change. It's still the same salt. All right, and that's my one thing. And you can easily turn it back. So the same salt you change from the liquid salt that you see there, and you put inside water to make it solid. All right, you can later change it back again from liquid to what? Solid. Same thing with sugar. All right, when you dissolve sugar in water and in short, do you know that sugar that the sugar that you like a powder, the sugar is made from sugar cane. I don't know if you're aware. Sugar is obtained from sugar cane. How did they do it? When they harvest the sugar cane from the farm, they will wash it, right, and they will now grind it. There are engines that has the ability to grind, so they will grind the sugar cane, and they will now filter the water through filtration. When they filter the liquid of the sugar cane, they will now subject to heating. It will heat it until the liquid evaporates, and what you have left is the powdered sugar. That's how sugar is obtained. So sugar is actually obtained from what? Liquid, and it now becomes solid. That's how you can carry them back to one place to another. You can preserve it, and so later on, if you want to sip Gary, you just fish it and put it inside again, and you still have your sugar. If you decide to reverse it back, as if you put a teaspoon of sugar inside water, and you want to reverse it back, just heat it. When you subject it to heat, it will become solid sugar again. That is what you are saying, the dissolution. Number 2 is example of physical change is changes in state of matter, such as melting of solid. Now, let me say you carry your a plastic container, your plastic rubber that is in your house, your bathing bucket, and you put inside fire. How do you know it will melt, right? It will melt and it will become liquid. And you know that if you touch that liquid, it is very hot, right? Now, so a time will come when the liquid, when it cools, it will form solid again. Do you understand what I'm saying here? When it cools off, it will become solid again. That's what I'm saying there. So when you melt a liquid, it will be liquid. So when you make the solid like container, it will become solid. It will become liquid. Then later, when it cools off again, it will become what? Liquid again. However, you still have the same rubber, but you know that you will not have the same shape again because the rubber will melt. So it will not have the same shape, but it is the same rubber that you are going to have the same content of the rubber. You are still going to have back. You will not have a new solution. You will not have a new substance. You will have the same substance, though the shape may change because you melted it. The next one there is freezing of liquid, like I told you. If you carry your pure water, you put it inside the freezer and it freezes. That's the physical change that has happened. The molecule have just been brought together, nothing much happened to it. So you can easily carry that same water, put in the water, that same block, that same pure water, that block, put it inside the pot, and you heat it, it will become solid again. And that is it. There's no new thing happening. Evaporation of liquids, likewise, evaporation of liquids. So when we have
Huh? Water full you off it? No, the water
is not already. I don't know. A full, I don't know. Sorry about that. I had to answer something. All right, let's carry on. Okay, so we have evaporation of liquids. So like I told you about the case of sugar, like sugar cane, or even your milk, your powdered milk. I hope you know the milk. You know that the milk is actually liquid when it's being milked. Yes, from the cow. You get it's liquid. So what they simply do is they will subject it to heating through the pot. I think it's called through the evaporation. And when that happens, when all the liquid evaporates, you have your powdered milk. Although there are other processes they carry on, but this is the major thing they do to turn liquid milk to milk powder, solid milk. Then there's also the liquefaction of gases to solid. Liquefaction of gases to solid. Let me read what that means. Let me just go to my notes. Let me read what that means. I think I did a little study on it. Okay, let me go to there. All right. Let me read a little. All right. So what is liquefaction? Liquefaction of gases. Please, you can write this down. I not in the note. It's not in the note, so please put it down because it will help at some point. All right. Liquefaction of gases is the process of converting a gas into a liquid state. It's called liquefaction. The process of converting gas into liquid state. The process of converting gas into a liquid state is called liquefaction. This is typically achieved, now listen now. This is typically achieved by increasing the pressure. I think I've seen this kind of question either in WAEC or JAM chemistry when they asked what method is used to convert gas into liquid. So just follow now, listen very well. It's called liquefaction. And how is it done? Number one, it said this is typically achieved by increasing the pressure. So when you increase the pressure and decrease the temperature of the gas, you cause that is, let me just read from here if I explain. This is typically achieved by increasing the pressure and decreasing the temperature of the gas, causing the molecules to slow down and come closer together, eventually turning into liquid. So when you want to convert gas into liquid, you simply increase the pressure on the gas, then reduce the temperature, because it's the temperature that is changing into gaseous. Just like I told you about water. If you should carry water and put in a pot and turn it on and it heat and it go beyond 100 degrees Celsius, that's the boiling point of water, 100 degrees Celsius. When you go beyond 100 degrees Celsius, the water will begin to evaporate at a very high speed because it's too hot. Now, when you decide to reduce the temperature and turn it off, and you now carry cover the pot, you notice that same vapor that is trying to evaporate will become liquid again. I don't know if you have noticed that. When you're cooking, you can open your pot, you see water dripping from the cover of the pot. That is what is happening there. It's liquefaction, where you are transforming gases into liquid. All right. Let me read further. For example, think of it like this: when you breathe into a cold window, the warm air gas melts the cold surface and turn it into tiny liquids of water, tiny droplet of water. This simply I'll just give you an example what I say about your water evaporation that happens. All right. Now let's look at. Okay. Cherry, sorry about that. Your network is not good. I understand. Don't worry. I'm just try. Okay. I'm making a video as well, so I will try to make it available on YouTube. I'll send the link to you and to anybody that want to. All right. But just stay around. I'll try to go over it again. All right. Let me keep reading. So I'm explaining liquefaction, and I'm saying that it's the process of converting gas. Please write it down. It's not in the note, so I just got this. So write it down. Liquefaction is what the process of converting gas into liquid state. And how do you do this? By increasing the pressure and decreasing the temperature. Increasing the pressure and decreasing what? The temperature. So like I give an example, you're boiling water and the water begins to evaporate. Maybe you are boiling the water, you now open the pot and it's going. Now, to convert that gases that is going on, that vapor is gases, right? It's gaseous state of the matter. To convert it back to liquid, you simply apply pressure by covering the pot, then turn off the gas. The vapor will now become liquid again. So when you are cooking, you notice that when you open your pot, you see what droplet of water dropping. So that is what is liquefaction. All right, let's carry on. Another example of physical change is sublimation of solids. Sublimation of solids. And let me read that again so that we can take the note. Let me read that again from my notes that I have here. I'm not included this in the PDF. That's why. Now, sublimation. Now, you can take it down. Sublimation is when a solid changes directly. Sublimation is when a solid changes directly into a gas without going through the liquid phase. Sublimation is when a solid changes directly to gas without going through the liquid phase. So this is like magic, because what we usually know, for example, you have pure water and you have an ice block, and you want to convert it to gas. Simply put it in the pot or in a kettle, then turn the heat on, and the thing is heating. The pure water will melt to liquid first, then begin to boil, then convert to gas, right? But they're saying in sublimation, it is possible to boycott the liquid state and fly directly to gaseous. Do you get this thing? So sublimation is what? A process by which liquid is changed directly into solid where solid is changed directly into gas without going through the solid phase or solid state. All right. Now let's look at example like dry ice. Dry ice, that is solid carbon 2 oxide. Carbon 2 oxide turns into carbon dioxide gas. So there is carbon 2 oxide, which is solid. When you convert it, when you subject it to heating, it will become gaseous. All right. There's another malt ball, which I've not read on this, but I will. Malt board can turn into gas. Snow or ice can sublime into water vapor. So even snow, all right, snow or ice. So you have your snow, and at its heat, can just become ice again. So that is sublimation, the process by which solid change directly into gas without going through the liquid phase. Okay, I'm making progress. All right, any questions so far? Any question? Okay. Cherry, what about you? Any question? I know you are just joining. Okay. Please, you have any question, feel free to ask. Okay, let's carry on. Chemical change. We are done with physical. Okay. Are we done? We're not done. There's a more example of physical change. I'll just read through. There's magnetization and demagnetization of iron nails. Yes. That's the second. That's another physical change. Magnetization and demagnetization of iron nails. That's number 3 example of physical change. And number 4, final one, separation of mixture by evaporation, distillation, fractional distillation, etc. We're going to look at all these what I just mentioned here when you're looking at separation techniques. We look at evaporation, we look at distillation, we look at fractional distillation, we look at evaporation, we look at crystallization, we look at titration, and so on and so forth. These are separation techniques. So I think it will be in our subsequent topics that we are handling. All right. So please just keep gluing to the classes so that we learn. I'm trying to lay a foundation here. So just ensure you are in every class. Don't miss any class. We're going to discuss each and every one of them: evaporation, distillation, fractional distillation, there's crystallization, there's titration, there is filtration. These are separation or techniques. All right, let's carry on. So that is the 4th example of physical change: separation of mixture by evaporation, distillation, fractional distillation, etc. Then let's move into the chemical change. So that is that we have explained on physical change, and we say that physical change is a change which is easily reversible, and there's no new substance form. And I give an example of water. You can carry pure water, all right, one pure water, and you can put it in the freezer and they become they become ice, all right. Then that same pure water, you can reverse it back again to liquid if possible. So that's what they're saying here. Then let's look at chemical change. So chemical change is a change which is not easily reversible and in which new substances are formed. So in chemical change, it's not easily reversible and new substances are formed. So when you combine compounds together, you combine certain state of matter together, then they can give you another substance entirely. So we are going to look at that as we study Example of chemical changes are: number one, rusting of iron or metals. Rusting of iron or metals. Rusting of iron or metal is a chemical change. All right, that you can, if an iron get rust, it will be difficult for you to change it back to a fine iron again. I don't know that you have ever seen a rusted iron before. You'll notice that it will, the shape, it will be something else. It can even be sometimes to be as if it's sand. You can't change it back again to the iron it used to be before. You can't revise it. That's a chemical change that took place. All right. Number two is dissolution of metals and limestone in acid. Dissolution of metals and limestone in acid. All right. So limestones are actually, yes, there are stones, solid. Okay. So when you subject them or mix them with acid, they can give a new substance, and it will be difficult for you to actually change it back again to what it used to be. Then number three is fermentation and decay of substances. Fermentation and decay. Okay, let's look at this example. You cook food. You cook a good plate of a pot of rice, and you forget to warm it. You know what will happen the next day. It will become fermented. It will become what you call sour. That's fermentation. You realize you cannot, no matter what you do, you cannot change that rice back to the normal rice again. You can't even eat it. No matter what, no matter how what you put inside, you're like, there is too much meat inside of it. Are you following? So even if there is too much, okay, even if there is too much meat inside of that thing, and you feel like this rice, it was too sweet yesterday, I can't throw it away. You can't change it back to what it used to be. You can't reverse it. Okay, that is fermentation and decay of substances. If you carry grasses and the grass become decayed, you cannot change it back to green grass again. Not possible. So that what happened there is a chemical change. So chemical change are not reversible. All right. The next one, number four, we have changes in electrochemical cells. Changes in electrochemical cells. Electrochemical cells are like battery. Like, let's use battery for example. Battery is an electrochemical cell. All right. Now you realize that. Let me use your phone battery for example. Now, your phone battery is very good right now. Let me mute your mic for this. All right. So your phone battery is good now, but you realize that if your phone battery gets swollen, it will not serve you the way it used to serve you. It has become something else. It has become something spoiled. It has become something else, and you can't reverse it back again to a normal battery. Let's say your touch battery, you bought a touch battery and you have used it, and the battery is weak. The cell is dead. No matter what you do, it will not become. If you like try it and rub it on the floor 50 times, 100 times, it will not change back to a new battery again. That's a chemical change that have taken place there. That's what they're saying there. Okay, let's carry on. The next one we have is addition of water to quick lime. Addition of water to quick lime. Okay, now you put you bought lime orange or lemon. Let me use lime for example. You know lime orange, that's tiny orange that is very sour. You bought lime from the market and you now squeeze it into a bottle. When you squeeze it into a bottle, you now add water into it. That's a chemical change. It's no longer water. It's no longer pure lime. All right, there's a mixture. Do you understand that? Now you cannot. There's no possibility of you separating water to be on its own again and separating lime to be on its own again. Not possible. It's a new solution. Okay, let me use another one. Tea. Tea and water, your Bonvita, right? When you put hot water or any cold water, however you call it, and you fetch a teaspoon or tablespoon of tea of your Bonvita and put inside the water, it's no longer Bonvita, it's no longer water, it's now what you call tea. So you cannot separate the two of them and ask, okay, let me have Bonvita alone and let me have water alone. It's impossible. And this, I think there's a name they call this kind of mixture. I think I did that in last class. There's a name. Let me check the name. Sorry, just hold on. There's a name I call that kind of. It's a mixture that cannot be separated. Okay, just hold on. Let me check the name so I will tell you. Okay, just hold on. I'm looking for it. Okay, good. They are called immiscible what liquid. They are called miscible liquid. Sorry, they are called miscible liquid. Miscible liquid are liquid that you can, if you mix them together, they'll give you another different liquid, another different something different. So you mix this. If you mix lime, all right, lime and water together, you cannot separate them. They will mix, and you will not know it's lime water except you taste it. They are called miscible liquid. You can mix them, and you will not know. But immiscible liquid are liquid that you cannot. If you mix them, somebody will know you mix them. For example, you carry water, oil, and put inside water. Oil will ascend up. Oil will float. Water will be down. You carry foil and put water and put inside foil. The foil will float. So the foil and water is an immiscible liquid, while lime and water is a miscible liquid, because if you turn it, it will become the same. You don't know whether there's lime inside until you taste it. Do you get what I'm saying here? So what happens between lime and water is simply a chemical change. The last one is burning of materials. So when you carry let's say you have some old clothes that you don't like anymore, you took them outside and you pour fuel and you set it on fire, it will burn, right? It will burn and become ashes. So ashes is now a new substance that has been formed. The thing is neither cloth nor fire, it's ashes. All right, so you combine fire and you combine cloth together and you burnt and it burnt, so it form ashes. That ashes is a new substance, and you cannot revert that ashes back to cloth or reverse it back to fire. I don't know where you're getting this thing. This thing is just simple. Is a very simple explanation to just chemical change that happened there. Okay. All right, so that is simply it. So we look at the rusting of metals as an example. We look at dissolution of metals and limestone in lead acid. Look at fermentation and decay of substances. We look at changes in electrochemical cells. We look at addition of water and quick lime, addition of water to quick lime, and we look at burning of materials. Now let's look at the comparison differences between physical change and chemical change. All right, number one is physical change is easy to reverse. It's easy to reverse physical change, and chemical change is difficult to reverse. It's difficult to reverse. It's difficult to reverse. Number two, no new substance is formed in physical change. There's no new substance formed with the same thing. While in chemical change, new substances are always formed. So in a chemical change, I can give you an example of cloth and fire. When you set your cloth on fire and it's burned, it becomes ashes. Ashes is a new substance that will be formed. All right. Number three is very little energy changes take place. Very little energy changes takes place. Very little energy changes takes place. Number four, there are often large heat changes that change. Often large heat that change in chemical change. Then number four, last but not least, no change in mass. There's no change in the mass. I told you the same pure water is the same pure water. But for chemical change, the new substance formed have different masses, but the total mass is unchanged. Are you getting what I'm saying? The new chemical formed have a different mass from the original mass, but the total mass will not be changed. Okay, so that is that. Okay, can you hear me? That is that. I don't think network went off, so I paused. All right, so that is that concerning physical and chemical change. So any questions so far? Any question? Do you have a question? If you have a question, feel free, go ahead, drop the question in the comment section. Do you have a question? Do you have a question? Are you there? You have a question? Please, you have a question, unmute your mic and ask. If you don't have, we carry on. All right. Let's see. Hope you can still hear me.
Yes, sir.
Okay. let's look at this. So there are some questions which I would like us to answer. So you can go to the question part. So what I want you to do now, you're going to use your pen, you're going to use your book. As you read the question, you're going to tick what you think it is. Don't check the notes. You're going to tick, you're going to write what you think is the correct answer. If it's A, you write A. If it's B, you write B. If it's C, you write C. If it's D, you write D. As we finish all the 5 questions, I will now give you the answers. Then you will now mark yourself to know how many you scored. Then you tell me how many you scored. Do you understand?
Yes, sir.
All right, let's carry on. Number 1. Okay. Which of the following changes in a chemical change? Which of the following changes in a chemical change? A. Melting of ice. B. Liquefaction of air. C. Slacking of lime. D. Evaporation of a liquid. Which of the following changes in a chemical change? A. Melting of ice. B. Liquefaction of air. C. Slacking of lime. D. Evaporation of a liquid. So what do you think the answer? Put it on. Number 2. Which of the following substances will occupy a wider space? Which of the following substances will occupy a wider space? A. Carbon 4 oxide. B. Liquid milk. C. Piece of chalk. D. Water. A. Carbon 4 oxide. B. Liquid milk. C. Piece of chalk. D. Water. Which of them will occupy a wider space? Number 3. When a solid changes to gas directly. This process is called dash. A. Freezing. B. Sublimation. C. Vaporization. D. Evaporation. When a solid changes to gas directly is called what? A. Freezing. B. Sublimation. C. Vaporizing. D. Vaporization. And D. Evaporation. Number 4. Which of the following changes produces a new substance? Which of the following changes produces a new substance? A. Reaction of water with sodium chloride. B. Addition of acid to base. C. Turning of margarine to oil. D. Evaporation of water. So which of them will produce a new substance? A. Reaction of water with sodium chloride. No sodium chloride, that is salt. B. Addition of acid to base. C. Turning of margarine. Margarine is your blue band, all right, your butter that you use for bread. So turning of margarine to oil. D. Evaporation of water. Number 5. Which of the following has a fixed shape and volume? Which of them has a fixed shape and volume? A cube of sugar. B. Liquid wax. C. Smoke. D. Kerosene. Which of them has a fixed shape and volume? A. Cube of sugar. B. Liquid wax. C. Smoke. D. Kerosene. Are you done?
Yes, sir.
All right, let's now be ready to mark. Of course, question number 1. Let's see. So what was your answer? What was your answer, question number 1?
Number 1.
Yes.
C.
You say?
C.
C. Is it C or? C, right?
Yes, sir.
Yeah, C is correct. Slacking of lime, yes. C the correct answer. Then number 2. Number 2.
I
Yeah.
did not do that one.
Why did you do it? Will you in exam you leave it like that?
I did not know the answer.
One trick you must learn in exam or in jam is don't ever leave any question unanswered. Do you understand?
Yes, sir.
Yeah, whether you know it or not, just pick any option. You can be correct. They won't punish you if you are wrong. So just don't leave any question unanswered. You may be right. So you can just put anything. If you don't know the answer, just fix anything and you move. Do you understand?
Yes,
Yeah, it's a trick that you use for jam. You are writing your jam, or even WAEC. Don't leave any question unanswered. Ensure it's objective. Just pick anyone and you move. That is it. Now, so the answer there is which of them will occupy. Let's reason together. Which of them will occupy more space? They say yes, carbon 4 oxide. Carbon 4 oxide is gas. You understand?
Yes, sir.
Now, gas is air like breathe, like air, right?
Yes, sir.
So when you're breathing in and you're breathing in oxygen and you're breathing out carbon 4, carbon 4 oxide. Now, so this is air. You are releasing into the air. So it is likely that because you are releasing carbon 4 oxide into the air, it will occupy more space than a piece of chalk and liquid milk and water. Don't you think?
Yes, sir.
Do you know why? Because air is not, you cannot, how will I put it? You cannot confine air into a particular location. Air is, whether it's everywhere, right?
Yes, sir.
So carbon 4 oxide is the answer. It will occupy more space than water. You can confine water in one place. You can confine milk in one place. You can confine your piece of chalk in one place. But you cannot confine carbon 4 oxide. So that carbon 4 oxide is the answer. So the answer is A. Number 3. What's your answer? B, yes. You did the correct thing. Sublimation. Number 4?
B.
Number 4, B. Yes, adding of acid to base. Yes, exactly. It's correct. Number 5?
A.
Yeah, it is correct. Correct. So you did well. You did well. A is the correct answer. A cube of sugar is in a solid shape. So well done. You did well. It means that you understood all the noise you just made. Well done. All right. So, but do you have any other question to ask?
No, sir.
All right. So this is the end of our class for today. So in our next class, we shall be. Meanwhile, the math assignment that you say you've done, you have not submitted it. Please submit it. Okay.
Okay, yes, sir.
Yeah. Let me see it. So in our next class, we look at elements, symbols, and valency. We're looking at the first 20 elements and so on and so forth. So ensure you are in the next class. All right.
Yes, sir.
And tomorrow, let me announce. You say?
Sir, those math questions I gave you.
Yes.
The first one. The first one.
Yes.
I don't think the question is correct.
What was the question? Read them here.
23 base x plus 14 base x because 43 base 10.
Yes.
The question is correct.
It's correct now.
Well, I'm guessing. Okay. It's good. The
All right.
second one. Okay, I got 12 in that one.
I've not solved the question. No. I just gave you. You get. You mean that I've not solved it. When you solve it, I will know you got it right or not.
Okay.
When you submit. Okay.
Yes, sir.
Yes. All right now. So ensure tomorrow is physics. So ensure you are around. Okay.
Yes, sir.
Yeah. All right now. Bye bye. Take care. Bye for now.
Okay.
All right. Are you there? Can you hear me?
Yes, sir.
You can leave a comment in the group. You can comment out to this class. I was to this class. You just leave a comment in the group. Okay?
Yes, sir.
Yeah, to encourage others that they will know that something is happening. Thank you.